Event sourcing. So the talk is actually 10 years of event sourcing, but I've learned that the audience can be have very different experiences. So let me verify that first. So who actually knows what event sourcing is? Oh, half of the people. Really? Like you really know what event sourcing is? Are you not confused with event streaming or something, or event-driven architecture? Okay. Because sometimes I have to do the introduction. So who needs an, well, can I skip the introduction? Do you actually want me to start over? Yeah, start over? Okay, I'll see. Because it's only 40 minutes and I can easily talk a full day about any topic. Whether it's test-driven development. Oh, one more check. Who is actually a .NET developer? Just checking. Oh, a couple of people. Okay, okay. Because some of the examples are C#, but it doesn't really matter whether it's C#, Java, TypeScript, they all look the same these days, right? And if not, you use an AI to convert from one to the other, I guess. I've completely changed my mind about AI. Like the last 2 weeks, I think 90% of what I produce was written by AI. It's still my code, but it really makes a difference. I wonder how many people are actually using AI every day? Not just ChatGPT, wait. But actually using cloud, Copilot, stuff like that to generate code. Okay. Who actually understands that code? Okay. You're very honest. There's a lot of interaction here. I like that. All right. Let me start. 10 years of event sourcing. Yes. Who am I? Doing a lot of development for the last almost 30 years, mostly in the .NET space, obviously with a front end in React and Vue.js. And I work for a small, nobody cares about that, but anyway, a small firm in the Netherlands as a consultant. Usually means that I spend a lot of time with my clients, working with the teams, on one side being the architect, on the other side actually coding with the teams. So I'm now 52, I've been doing this for 30 years, and I'm still coding like half of my time. Not just hobby projects or spikes, actual production code. And I love it. I really believe that a good architect should be coding. I'm not going to ask you who's actually still coding, because that can be confronting. I'm a Microsoft MVP, which means I should be talking a lot about Microsoft, which I don't. I hate Azure DevOps, I hate Teams, I hate SharePoint. But I do a lot of C#, to be honest. It's much better than Java. I'm not going to have that discussion at this conference. All right, and I do a lot of stuff. In case there's .NET developers, you may know Fluent Assertions, a small library that is notorious these days. I actually created that, but since then I've built I think in the last 12 months, 5, 6 new open source projects. So I'm really active in the open source community. It's not that I have time left. I mean, I have kids. I am the treasurer for my kids' handball club. I do coding. I have open source projects. I do talks. I have a full-time job. I game. I'm currently playing Death Stranding 2. Why am I telling all of you this? It doesn't make sense. I only have 40 minutes, but people are still coming in, so I'm trying to, break the ice a little bit. Anyway, so what is event sourcing? Because I've also discovered over the years that there's some misconceptions about it. There's also this other thing, CQRS, and a lot of people somehow confuse these two things. So, imagine an app, probably this now, I'll do this like this. Imagine an app, can be anything. What happens is this app will send commands, not commands, commands, things that you want the system to do. And is anybody in the domain-driven design space, like doing bounded context, aggregate roots, value? A couple of people. Domain-driven design is actually the process of trying to embrace your domain you're working in, understanding the terminology that they use, that the people in the business use, and they use something called ubiquitous language. Well, the ubiquitous language is basically the terminology that the business uses. If they call somebody that pays the bill and they provide a service, if they call the client, you are supposed to call the client. If they call the customer, you're supposed to call the customer. Something like that. And if an order means something else in one part of the domain versus another part of the domain, then you actually should understand that and introduce things like bounded context. I'm not going to be explaining that because I have only 40 minutes. But the point is, this command is usually written in the language of the business. It is not create users, because we're not creating users. At least I haven't figured out how to create users or create clients. If I would be very rich, you have to work hard to build a client. You at some point register. So that's what commands do. They contain information like the client has moved, or we found a new client, we registered a new client. So terms like create, update, delete, they should not exist. You don't delete a client. At least I hope you don't. You know, like killing them, I mean. Yeah, sorry. So if I have to explain my jokes, they're not funny. That's a problem I have. This will eventually land on some kind of, I don't know, it's HTTP API. I don't like to call it REST because it's completely overloaded term. And what happens then, we find some code that understands how to execute that request, that understands the domain, the business rules. We call that a command handler. You know that term. You've seen it thousands of times. And then we have the domain model. This is where your entities live. These are the aggregate roots and aggregates in general, and these are where the value objects live and where the invariants are protected. This is DDD, not important, but this is where everybody knows a domain model. This is where you have your client or your customer with relations and orders and stuff like that. This is all common. You've seen this. What is different is when we store that information, we're not actually storing it in tables. Well, we are technically can still store in tables, but we don't have a table like clients, customers, orders, and couple tables like, you know, that connect the two tables together. We don't have that. We have an event store, which is a very abstract term. And what we store there is events. So what we store is what actually happened in the domain. So you will find things like a client moved event. Not like the address changed event, because addresses don't change magically. They change because either the company moved to a different address or because they used a different billing address or something like that. We like to capture that. Just like the commands are using this ubiquitous language, the events are basically using the same language but then in the past tense. So if you actually register a client, then the event would be client registered. And it contains all the information so you can trace or understand what happened there, but from a functional standpoint. That is stored in some kind of database, and that can be lots of different things. There's dedicated solutions for that. There can be a relational database, but most people actually use a NoSQL solution. But it also depends, like, what is the typical database storage you use in your environment, in your system. Then we have, and this is, by the way, what they call the command side, or also called the write side. Not the right side, but the right side, WR. I can't make a difference. I'm not a native speaker. Then on the app side, on the left side, which we also call the read side, we need something to present information in this UI, this app. So the right side just executes commands and gives information back, like the command was processed, or some kind of validation error happens. Depends how you implement that. But the left side is where all the information is loaded. So what you find here is things like projections, and maybe some data access layer, and some kind of store that, you know, is optimized to reading this information as efficient as possible. And this is important. And then we have something which I call, and people in the community tend to call, there's different terms sometimes, that's confusing, but we have something that's called a projector. What does that do? It takes that stream of events that came from the command side and tries to project that data into a structure that is optimized for reading. So has anybody used like Hibernate and these solutions in the past, like ORMs? I don't know what people use these days. What do you use in the Java world, actually? Yeah, you can respond. I can. Not in Greek. I don't understand Greek. Well, these people come from. Are you on the wrong track? This is about event sourcing, right? Okay. Now, quite often, if you have a more traditional system, you store everything in tables like what I just said, customers and coupling, everything. And when you want to present that data, you probably have to, I don't know, do group by queries, stuff like that. Maybe you use views, which are generally just queries hidden in a different form. Maybe if you're an Oracle, I don't know if that's a common thing, Oracle. I don't like Oracle. You use materialized views, but in the end, you're always looking at the same data and trying to restructure that. And when the performance becomes crappy, what do? We add indexes, you know, because indexes make everything faster. Checking who has actually experience with indexes. And then it becomes, you know, you find another bottleneck, you add another index. And before you know it, you have a table with 10 different indexes, and the reads are really fast, but the writes are very slow, because every time you write something to that table, it either has to build up that index, which is actually technically a separate table, and if it's the primary or clustered index, it has to restructure the table. So that's a problem that you may have if it's a highly collaborative domain. Otherwise, you don't have that problem. Event sourcing, which is the right thing, the fact that we store it as a set of a stream of events, and this separation between queries and commands, that is actually CQRS, Command Query Responsibility Segregation, where you as an architect acknowledge the fact that those two worlds are governed by different limitations and different rules. And of course, this doesn't come for free, but it's pretty cool actually. What is cool is you can actually take those commands and replay them against different rules. It's a very hypothetical. I've never actually done that. And I've used event sourcing for roughly 12 years, I think, in production. But it's not that cool. What is cool is great for unit testing. A lot of people, I'm a big proponent of test-driven development. I build a lot of libraries around test-driven development and unit testing. Is a lot of people create unit tests against a class or method. So every unit test is one method or one class. I think it's a bad idea. I would call it a best practice or anti-pattern. I like to have my units encapsulate some functionality. So what with event sourcing becomes really cool is you can create a unit test that sends a command into your code base and then verifies whether a certain event happens. Everything else, is an implementation detail. The fact that you have an entire domain with business rules or invariants, as some people like to call them, it's an implementation detail. Yes, they're important, but this event should either trigger some kind of validation exception that you didn't actually meet a certain business rule, or it should produce an event. Greg Young, maybe you've heard of this person, kind of coined this whole idea. He once said, if you use a traditional architecture, you might actually verify that when you send this command, or you call this HTTP endpoint, as your UI would do, that the database table would contain certain data. Or maybe if you have a NoSQL solution, you can run this all in memory, or you use a database like Postgres or SQL Server in a Docker container, you can do that. But in the end, your test will verify whether the right columns are written. But quite often, or almost never, I guess, you don't verify that anything else was affected. Maybe your test is green, but it has completely deleted a different table. With event sourcing, that doesn't exist. The only thing that comes out of it is 1 or 2 or 3 events. Usually just one, because it's not just, we don't do property changed events, we're trying to encapsulate business logic and what happens in the system. So this is great. The flip side is that you have to really understand the domain. Your product owner or your business analyst needs to be part of the team, because you're going to be asking a lot of questions like, what should happen in this particular case? What happens if this field was not provided? How do things interact with each other? That's my experience. And that's pretty cool, because product owners are usually trying to work with the teams, but teams try to push them away, like you're just the person that talks to the business and we're the people that code. Or we tell Claude to do that for us. Has anybody done event storming? There's nothing, yes, of course, yes. A couple of people. Event storming, I've forgotten the name, it's an Italian guy. Yes, Brandolini. Of course. Yes, he came up with the idea where you actually sit with the business, or you stand with the business with these big white papers on the wall, and you try to capture what happens in the process. You don't capture entities or tables or columns, you actually capture what happens in this whole business process. Helps to identify different business people or different subdomains. And this works really well, because at the end, you're going to be capturing all these business steps into things that happen, events. So that aligns really well. Yeah, bugs. Yeah, we have bugs. I mean, until we had Claude and everything, we had bugs. And bugs are probably quite painful. They can be confusing, because, yeah, you have these event streams, and it might take a while to understand what happens in the system. On the other hand, aren't bugs always difficult, especially in production? I guess, yeah, depends. You don't create bugs? I can see your face like, what is this thing you talk about? Bugs. Yeah, okay. And this is really awesome. You can actually go back in time and see what happened. You can actually replay, based on this event stream, what happened in production. We had some pretty serious production issues, and because the system was running on an OR platform, which was not connected, we could just get a dump of this event store, and then replay what literally happened in the UI and understand what the people were doing. We don't actually see an audit trail like, this column was changed, but we understand what somebody did. like a valve was closed, and then another valve was closed, and then the other thing didn't happen, which we would actually expect that to happen, which is a big difference. Yeah, versioning. Yes, events are stored and they're idempotent. Sorry, they're not idempotent, they're immutable. So you actually have to think about like when things change. Code changes. You know, code changes a lot, especially with a good product owner and your successful product. You have to deal with new requirements. This is complicated. I probably have a slide if I don't stop talking, if I stop talking too much. A lot of developers perceive as complex. Check. Who thinks this sounds really complicated, honestly? Or you feel that your people around you will be, because you don't think it's complicated, right? You get this. But everybody else will probably be complicated. Yes, yes, sure, sorry. It is different complexity. If you've built serious enterprise systems, you know, with N+1 performance issues and you know, distributed microservices with all these versions, that's also complicated. But it's different kind of complexity. Auditability obviously comes for free because you see all the events that happens. And you can replay production, I already mentioned it. Another reason, and that's how we used it, you can actually use it for replication. Of course, a lot of databases have replication out of the box, but quite often it's limited. But here, because you have this nice stream of things that happen over time, all in small chunks, you can just replay those events on the other side, on a different place, and rebuild this whole database from scratch. And you have a nice checkpoint that you can use for synchronization. You don't need relational table structures anymore. Why would you use a relational database on the query side, on the left side of that picture, if you can use an optimized NoSQL database, which uses, for example, asynchronous tables or asynchronous views? In the .NET space, we use a lot of RavenDB, but Mongo and all the other ones are also very popular. You don't need SQL or Oracle. You can just drop it. It's a good reason, I guess. Yeah, the whole projection thing can be complicated, especially if you build everything asynchronous, because you really want a high-performance system. And it's quite difficult. Like if you build a domain model in the past, you probably had an entity, and that entity had, for example, a property called orders that pointed to the other entity. You don't have that anymore, because entities, or technically aggregates, are supposed to be independent because they're stored separately. The events only affect individual groups of events. Groups of entities. This is a bit difficult to imagine if you haven't seen this. And this whole this projector thing, they're basically supposed to be some kind of cache, kind of like a view, which means if your domain model changes a lot between versions, you might have to rebuild those projections. This is complexity a lot of developers underestimate that you have to deal with, and it can also take a lot of time. We've had a lot of experience. And you know, this 40 minutes is barely enough to touch like the top of the iceberg. But the slide deck contains a lot of different additional slides that talk about strategies that we use to make all this whole projection thing faster. And after 10 years, you've tried a lot. So for the really experienced people, if you want to read that afterwards, you can check out the slides. I will share that. What else? Yeah, you may require some end-to-end testing to really understand like when a command is being sent, how this whole event, the whole thing. But on the other hand, these days, that's quite common, right? I mean, every system is complicated, and you want to have end-to-end tests. In my ideal world, we don't have testers anymore. We have quality assurance engineers, people that really help the team understand how to make things testable and invest in automated testing. I don't want people to, after a pull request is being merged, throw it over the wall or over the fence and have somebody test that. No, I want this to be automated. This is the way it's supposed to be. Check. Who's doing unit testing? Automated testing in general. Half of the people. That's not much, actually. That's not much. I suppose everybody else is a manager and architect, just drawing pictures. That's your excuse. Okay, I'm just going to skip a couple of things. This is what an aggregate can look like. This is a user, and it has a base class, but this is a custom implementation. I don't actually know what libraries exist in the Java world, but in the .NET space, there's a lot of libraries that were created and then died off, and then new ones are created and forked, and it's almost like a moving target. Like every time I do this talk, I need to check again, like, what are the active libraries? There's a couple of them that are very active, but this is, of course, not an architecture style that you should apply by default. It's not like now, next Monday, you go back to work and say, we're going to do event sourcing now. Why? Yeah, because it's cool. Well, it is cool, but it's something that you should consider. Just like a lot of people seem to be doing onion architectures and clean architectures without actually understanding why they need it. I hope nobody's now wondering, oh, really? Oh. Anyway, but this is something like a user. This is a C# class, obviously. And what you see is that, for example, if you look at the constructor, you can recognize a constructor, right? Everybody knows what a constructor is. Instead of updating some class variables, or fields as they're called in C#, what it's actually doing, it's applying an event on itself. User-created event. Here, mistake 1. What did I just say about users? They don't come out of thin air, right? You don't create them. Well, this is a bad example. But it is an event, and you see it has an identity, username, full name, and some UTC creation time. And what this does, it actually updates an intermediate state, and that is stored in the user state. I have a separate picture. And then there's properties, for example, the username, and what it does, it actually loads it from some other class that is connected to this. But at storage time, we don't care about the state, we're actually storing the events. So this apply thing basically keeps track of events that happened since this entity was loaded from the database. Here you see another thing, like I'm changing the username. Okay, so what it's doing, it first checks whether the username is changed and then applies an event to itself. That is what happens. That's what happens. And you can build it in different ways. And this is what an event could look like. These are all simple fields. They're supposed to be all using a private type. This username thing, you see here, username is of type username. Username is not a type in .NET. Somebody created that. You should not be doing that. Because an event is something that will never change. It's stored on disk or in your database. Imagine that this username type changes the structure, changes the variables, like a username needs to follow a certain structure. That could change in the future. I don't know for what reason, but it could change. Imagine then this event is loaded from this event store, and then the framework or whatever you're using is trying to deserialize this storage, usually JSON or some other format, back into this entity, then this whole thing will explode. So you should only use private types. I know this, I should have fixed the slide actually, but it's good, I'm making mistakes as well. This base class could look like something like this. It's very complicated. Well, let's say it's non-trivial, but this is an example. And here you see the apply. What does the apply do? It actually adds the event to a list of changes to track that. And what does it also do? It somehow updates the version, and then it tells the aggregate state to do something with the event, which is probably updating the properties that are used at runtime. And it does all kinds of other stuff, like raising a domain event so that other parts of the system can also respond to something that happens because your entities are not connected. This can become complicated quite fast. And this is what happens at load time. So when the thing is loaded from the database, what happens, it creates an instance of your entity. In this case, it was a user, I think. Yeah, it loads it from the database. It clears that list of changes, and then it gets a list of events loaded from the event store, process them one after each other, which actually means it just updates the runtime state of this object. It's just an object. And tracks the version. And every event that you apply increments the version. So instead of using an ORM where you're saying I'm loading a record from the users table and I'm mapping those columns back to the properties, we're loading a stream of events that happened since the user was created, and reapply that to the object. Yes, that can be quite a performance bottleneck, but it really depends on the system. Then you have advanced techniques like snapshotting and everything. This is what the aggregate state looks like. It's a simple class with properties, or fields, or whatever you want to use for that. And this is what this when method does. I'm going to skip some parts. This is really .NET specific, so I'm going to skip that as well. Yeah. This is a cool thing. So if you have a system with a lot of, I should stay here within the camera, a lot of like a lot of people modifying the same data at the same time, what usually happens? Well, if you didn't think about anything, you just overwrite each other's changes, right? You've done that probably, yeah? This is called no locking. Then you have pessimistic locking, where you somehow create a database lock so that nobody can update the data while you're working on that, which is not ideal in a highly collaborative environment. Then you have optimistic locking, and you use a version number or something like an E tag, where you're saying like, okay, I've loaded something from the system, I have a version number or something else in the UI, and whenever I make a change to the data, I pass in the same version number and this or something else to identify it. And when the database tries to update the data, it first verifies whether the version hasn't changed in the meantime. And if that happens, you get a message like, okay, somebody else changed the same record, please refresh the page and try again. You've built that, right? I can see people shaking their heads. So with event sourcing, you can do something different. We have this, on the left side, the time goes up, so you start at the bottom. In what is this? Red line indicates where we are right now. So in a database, I have an event, v3. It has a phone number added event, role granted, and user created. But in the same time, somebody else actually created a role granted event as well and changed the password, and the password was also changed on the left side. They were changed by multiple people at the same time. With optimistic locking, this will just fail and you have to restart over. With pessimistic locking, it doesn't even work. So what happens is the system will look at role granted event, compare it to all the events that happened since this red line, and say, is this a conflict? Is a role granted event, is that a functional conflict with a password change? Well, this is where your product owner comes in. But I suppose we can safely assume that those two things are not conflicting at all. So what happens is we say, it's green, it's not a conflict. Because we can look at the individual events and build code that actually compares them and defines them. Then this one, role granted, role revoked. Is that a conflict? Well, it depends. If it's two different roles, probably not a problem. If one was well, it's probably not possible to have one person removing something that didn't exist, but quite often it's not a conflict. So both are accepted. Now the next one, so role granted to, now this one, is that a conflict? Both changing the password. Probably yes. So it is. But this is where your PO comes in. Like, okay, what should happen in that case? That's usually where your product owner or the business analyst has a better understanding. And that's why event sourcing requires a much closer collaboration with with those people. I shouldn't call them like that. That sounds very negative. With those valued members of your team. Because it's a conflict. But in this case, we just accepted that the last one wins. And is this a conflict? No, this is not a conflict. This is not a conflict. So the password change is on top of the persisted state. This is pretty cool. We haven't used it that much, but we had a couple of situations where people were working offline on an oil platform, and the central system was also being maintained, where this was very helpful. Again, this is something you can use. It doesn't mean you should use, and that's applicable to anything. Evolve the domain, yeah. For example, you have this aggregate root, which is usually the entity that like the user, and then you have all kinds of related entities, like a value object, which is basically a simple a value type, like a class or type that contains like an ISBN number or something like that, that encapsulate business logic about things like you would usually store in a different object. What you can do, that is stored in event store, but the entities themselves are not stored. What we store is what has changed over time. So we actually know what happened functionally, which means you can actually rebuild your domain and completely, in a different version, use a different domain. You just interpret the same events differently. This is something we've done a couple of times. Because, yeah, 10 years, a lot of things change, especially if you're successful. This is something you can do. Why did we do it? Well, we had this construct of a centralized system somewhere on an onshore oil refinery, and then we had these oil platforms where people are also working, and what they wanted to do, they want to be able to prepare work onshore, like approve certain maintenance that they do on an oil platform. You cannot just, remove the electricity or shut down a valve or unscrew a pipe, because you probably heard about Piper Alpha, like these big accidents. So these people that built this system, they were in this oil and gas industry. And we needed a way to synchronize and being able to work offline and then work online and, resolve all the functional conflicts. And it should be synchronized, so we actually use that. And this is how it works. So on the left side, we have this query data and we have the changes. So the red boxes are basically all the events that happened. And that's what we call the primary node. And on the secondary node, which is a system being deployed on an oil platform, or a laptop, because they were also working in wells in Australia, in the outback, so they had a laptop where they had to work, and everything needs to be pre-approved if you're in the oil and gas. Like you need to do a risk assessment, you need to create an entire plan explaining exactly what piece of equipment is stopped or uncoupled or whatever in the right order, which needs to be reviewed. All of this happened online. And what we did is, because the changes on the left side is just a group of events ordered by time, we just replicated this on the other side, and that's fine. And the people on the right side that were working on the laptop or were occasionally connected to the internet, even in 2025, oil platforms don't always have great connections. It's still a problem. They could work offline, make changes, make changes to these permits, what they call them, and these isolation plans. And then we would actually synchronize, and if things started to fail because of functional reasons, we handled this event merging technique that we just talked about. So looking back, because this started in 2013, I still think this was the right architecture for that particular solution, but there's other options these days. And that's also, if you forget everything else I told you about, it is an architecture style that's very valuable and very useful, but yeah, you need to understand how it works and what the pros and cons, like any architecture, right? You don't apply a union architecture if you don't have a domain, a complicated domain. You don't build a microservice architecture just because your team didn't scale, right? At least I hope you didn't. Because we're not Netflix, unless there's somebody from Netflix here. How many people have built microservices? Yeah, of course. I knew that. I knew that. I have another talk about what I think about microservices. Anyway, I'll skip a lot of these details because of time. I have until, we started 5 minutes, or 10 minutes left. Wow. So, application sends a command, which is handled like the correct shipping address. You see the ubiquitous language in action. Then there's a customer entity, number 123. There's an event, and this is what we store in the database. And then we have another handler that responded to this event, like the shipping address changed. What does it do? It looks up all the orders and redirect the existing ongoing orders to the new address. All of this is handled through events and handlers. You see that. You also have sagas and stuff like that. But the thing is, you can actually go back in time now and see why was that order redirected. We track that in our domain. A couple of things. A command is a message. It's not a type. It doesn't contain validation logic. It's just a stupid message that you can send again, for example, to be idempotent. That's one thing. You need to have a partition key. So most entities, that have a primary key. That's usually a database thing. Quite often you have a functional key, which is the thing that identifies that customer outside the system. Never ever use a database sequence or automatically generated ID, because they will change if you shift databases. But wait, do you ever shift databases? Well, if your system is running long enough and is successful enough, you're probably going to change storage techniques, because a relational database is not the best solution. But if you have a lot of data, at some point you might want to ship or separate the data in a more functional way. And a partition key can be, for example, a regional thing, so that you can actually separate the data. That's really important for event sourcing, that you think of this something up front. Events, actually, it's on the wrong place. Events are not mechanisms that you put on a service bus as a mechanism to communicate between different systems. Event sourcing is an implementation detail of a particular domain or subsystem. It is not some kind of top-level architecture that you need to use everywhere. Events are implementation details. I've actually experienced a domain, a part of the system, a subdomain, where we used event sourcing, discovered that it wasn't actually warranted, and over time ripped it out. So events are not things that you exchange between different systems. You should use more coarse-grained events for that, because events will change over time. You're going to merge events, you're going to split events, you're going to rewrite or rename them. If you use them across different systems, it's going to be hell. So don't do that. Identity, yeah, it's the natural key. It should be the natural key. No, sorry. What I mean to say is the technical identity is not the same as the functional key. I already mentioned this. Another thing is, these events should represent functional things. I already said it. Ubiquitous language. We don't want property change. We don't want events address changed or something like that, and then have all the fields of the address there. or order changed event or something like that. No, it should represent what happens functionally. Otherwise, it's not going to add any value. You're building a very complicated system that's not going to solve any problems for you. And I guess we're using architecture to solve our functional, non-functional requirements, right? Not just because it's cool. Do we? Anyway, primitive types only, I mentioned that already. And yeah, okay, cover that. And the create, update, delete. We even build an analyzer for that. Yeah, that happened before we had AI. Now I just create a skill and say, don't use create, update, and delete in my events. And if you're lucky, it will pick up the skill and tell you. Sometimes it just doesn't pick up the skill. You have that? Cloud just ignores it. Like, why didn't you choose? Oh, I'm sorry. I didn't actually consider your skill. We'll try again. Yeah. AI, huh? It's like a real developer. Oh, I forgot to read the coding guidelines. But I told you about it. Yeah. Sorry about that. I will try to read it more. Granularity is also very difficult. Finding the right level of granularity. We had this thing where when you need to do this work on your old platform, you need to do a risk assessment. And a couple of people will actually look at the plan and what you're going to do and do an assessment. And if it's a risk assessment level 1, that's all fine, it's approved. But if it's a level 2, then you even need to build a team that does an extensive analysis. You need to select some certain subject matter experts. They need to evaluate the plan, try to understand if it's going to blow up the oil platform or not. So what happens if the analysis is done and it turns out that the risk assessment level for this particular permit to work is a 1 after all? Then 2 things can happen. You need to change the risk assessment level of that entity, but you probably need to remove the people that were assigned to that plan because they no longer need to do something. Well, you can do 2 things. You can have an event called risk assessment level changed, and then have 2 events. A risk assessment team member was removed, and another one was removed. This is wrong. Because yes, you can see that the level changed and 2 people were removed, and you may be able to deduct this because that other thing happened together. But functionally, a decision was made from, if you look at the business perspective, that the risk assessment level was demoted. I'm not sure if that's the right term. But we purposely had a meeting and decided that the level was too high, we should reduce it. The fact that it actually removed certain people from the entity is a result of that. It's not the real reason. This is what you're trying to do with the right granularity. And you're going to do it wrong. I've done it wrong many times. You're going to be wrong about this. Quite often, if you read the books about domain-driven design, they call it, I think, a breakthrough. At some point, you have so many conversations with the business and you discover that you've actually used the wrong terminology or the wrong business rules. And the point is then that you actually change the code base, you test everything to align with that. So you have to be really rigorous that the business and the code actually are in sync, which is a lot easier with AI these days. That's why we have versioning. So what happens is a command service executes a handler, or the handler actually handles the command. It will fetch the customer, in this case, custom with number 1, 2, 3. It will load the event. There will be a customer-created event. Again, this magic customer that just appeared from thin air. It will then trigger a converter. And what does this converter do? It may split or merge the event, splitting like into 2 events, or actually observe a couple of events and eventually emit 1 event, custom enrolled, which is the proper term. So even that requires code to do this properly because we care. And you can do this at runtime, like in this picture, but we've also had like whenever a new version of the product or the system is rolled out, we do a one-time migration, get all the events from the event store, rewrite them. But some people don't like that, but they say because the event store is supposed to be immutable. You're not supposed to tamper with history. So if it's a financial system, probably yes. If it's something else, you're in charge and you can decide that. That's up to you. But it produces a new event, and that is used to reinitialize at runtime this customer, and reinitialize its state. And then all the other unaffected events are being used. That's how versioning typically works. Well, I already mentioned this, and this is probably one of the last things I can tell you. It is not a top-level architecture. So if you have a system like, for example, a drafting domain, a policy execution domain, if it's about legal documents, and maybe some search domain. This is not one system. Yeah, maybe it's one application, it's deployed as one unit because we don't need microservices just because we love microservices. But we do have domains. We do want to identify that. That's why DDD is so important. But these domains or subdomains actually are driven or governed by different constraints, different requirements, non-functional, functional. Do we need, for example, is a drafting domain where you draft a legal document? Is that something that a lot of people are going to be involved with at the same time? Probably not. So we use a very simple domain. You know, we store using an ORM or some data access layer. We store this legal document in a database, and we don't need event merging, all this complexity there, because it's probably the lawyer that writes this document alone with the help of Claude these days, and that's it. Simple architecture, like a typical CRUD architecture. Execution may be involving a lot more, like this draft legal document needs to go to different departments where people have to approve certain sections, have to amend. Maybe that domain is warranted to have event sourcing with projections, so basically CQRS. Maybe that's something you can do. But you need to think about that. That's the job of an architect. Understand what architecture style is needed for what subdomain, not for the entire system. And searching, do you need any of that for searching? No, of course not. You just build something like, I don't know, Lucene Index, Solar, whatever we have these days in the cloud on AWS and Azure. And that is an important thing. I made this mistake, by the way. I actually thought like, oh, this is cool, event sourcing. I'm using it everywhere. And then we started to unwind. And then you use, this is an indexing-based architecture, maybe some message bus, you know, to have one subscribe to coarse-grained events, not event sourcing events, but high-level events that say something about what happened in the system. You know, when the drafting domain, when the legal document was approved or ready for review, then maybe an event is published about this legal document, which is then loaded into the policy execution domain, and then there will be a legal document in the middle of as well, but in a different form, optimized for having all these people work on that. That's what you're trying to do. And maybe there's a webhook where the search domain can use to get information about new changes and build up this index. Well, we're out of time, not surprisingly. So I'm going to, final slide. Would I do this again? Would I use event sourcing again? Yes. And if you're in the .NET space, there's a lot of libraries you can use on different places. I don't know about Java. I honestly didn't even know what kind of audience to expect here. But if you have questions, no, stop, jump to the end. Yes. Oh, I was going to the final slide. If you have questions about event sourcing, you can reach out to me. I'll be around at this conference for the rest of the week, especially tonight with the drinks, or tomorrow with the drinks, I'll be there. And I'm very approachable. Yes, you can actually talk to me and I'll respond. Not like, no, but just kidding. There's a lot of content. I will share the slide deck. There's even more there, all the performance improvements, all the complexities that we run into. But as I said, you can easily talk about this for a full day. I hope there were some elements and that it actually makes you think about, okay, this could be an interesting architecture slide. Thank you for your attention. I hope you enjoy the rest of the conference.